Hello everyone and welcome to Kiru's online lectures. I am Kira Jamtani and today's topic is Linear Inequalities Part 1. So in this part we are going to discuss introduction, inequations and how to solve this linear inequations in one variable. Coming on to the introduction part, in this chapter we will basically study linear inequation in 1 and 2 variables, and this knowledge of linear inequation is helpful in solving the problems in science, maths, engineering, linear programming, etc. Coming on to inequations, so a statement involving variable and sign of inequality is called an inequation or inequality. Like I am writing 3x minus 2 is smaller than 0. So since sign of inequality is there, so we call it as inequation. Now since over here only one variable is involved, so this is linear inequation in one variable. But if I am talking about 2x plus 3y less than 1, over here two unknown variables are involved. This is linear inequation in two variables. We can write 5x plus 4y smaller than or equals to 3. This is again linear inequation in two variables. Coming on to how to solve linear inequation in one variable. Right now we are talking about one variable. So the type 1 which we have, that is ax plus b greater than cx plus d, or ax plus b greater than or equals to cx plus d, or ax plus b smaller than cx plus d, or ax plus b smaller or equals to cx plus d. So when linear inequation in one variable is given of the form, these forms are there. So there are certain rules to obtain the solution of these linear inequations. First rule is obtain the linear inequation, then collect all the terms involving variable on the side of the inequation and constant term on other side, like x variables on the other side and constant variables on the other side. Then we will simplify both the sides of inequality to reduce this inequation in the form of ax smaller than b, or ax smaller than or equals to b, or ax greater than b, or ax greater than or equals to b, depending on the question what is given in it. Then we will solve the inequation, that is obtained in rule 3. By dividing both sides of the inequation by the coefficient of the variable. Like here the coefficient of x is a, so we will divide both the terms by a. Then whatever we obtained in this rule 4, we will write it in the solution set in the form of interval on the real line. Now these are the rules for type 1 type of linear inequation. Coming on to question part. So the question is 2x minus 4 smaller than or equals to 0. Since over here already x is on the one side, so the constant term we have to shift on the other side. Whatever constant term is there, that we will add over here, and on the RHS side also will add. So this and this got cancelled out. 2x is smaller than or equals to 4. Now dividing the coefficient of x on both the sides, 2x by 2 and 4 by 2, thus we will get x is less than or equals to 2. Since whatever we got over here, we will plot it on a number line. So this is our number line. Over here we have plus infinity, here we have minus infinity. Let us suppose this point is 2. So this point, this is the number line which represents x is less than or equals to 2. Less than 2, that means if we will write it in the solution set, so we will write minus infinity to 2 where 2 is included, because over here equal sign was there. When 2 is included, we put over here a square bracket which represents closed interval. Coming on to second part of this question, over here it is given 7x plus 9 greater than 30. So we have to remove 9 from here. So we will subtract 9 and same 9 will be subtracted on RHS side. So we will get 7x greater than 21. Dividing by 7 on both the sides, we will get x is greater than 3. Now whatever we got over here, x is greater than 3. So its solution set will be, now over here no equal sign is there. So we will write it in open interval, which is 3 to infinity because it is positive. Now when we will draw a number line, this is plus infinity, this is minus infinity. We know over here we have 0, 1, 2, 3. So 3 to infinity represents this linear inequation, where 3 is represented by this circle. Coming on to next question. The next question is solve 5x minus 3 smaller than 3x plus 1, where 3 conditions are given to us. We have to find x when it is a real number, when it is integer, and when it is a natural number. So first we will solve this equation. We will get 5x minus 3. The equation linear inequation is 5x minus 3 smaller than 3x plus 1. Now we will do shifting 3x to this side, transposing coefficients, so transposing variables in constant term on this opposite sides. So here we have transport this variables and 3 is transported over the RHS side. So we will get over here 2x is smaller than 4. Now dividing 2 by both the equations, we will get x is smaller than 2. Now x is smaller than 2 when we write it in since first condition was x belongs to real number. So when x belongs to real number, x is smaller than 2. So here x belongs to minus infinity to 2. We will draw it on a number line. So this will be our number line, where this is represented by plus infinity, this is minus infinity, 0, 1, 2 over here. Now from 2 to infinity, minus infinity, so this is number line. But when it is said x is an integer, so integer is represented by z. So x is smaller than 2. So x is smaller than 2. Since we have to write it is an integer, so it will be x is equals to 1, 0, minus 1, minus 2, minus 3, minus 4. But since over here only integers are set, so we will be writing these integers only. So thus the solution set of this will be minus infinity to minus 4, minus 3, minus 2, minus 1, 0, 1. Coming on to next, when they said x belongs to natural number, the third part. So when x belongs to natural number, since x is smaller than 2, so this implies that x will be only 1 because 1 is a natural number. So its solution set will be 1. So this is how we applied rules to solve this linear inequation in one variable. Coming on to next question. The next question is 1 upon, we have to solve 1 upon x minus 2 smaller than 0. So we have rule when a upon b is smaller than 0. So and a, as we can see over here, this is 1 and a is greater than 0. So this implies b should be less than 0. So over here, since it is following this condition, we will write x minus 2 smaller than 0, thus x will be 2. So x belongs to, since it is smaller than 2, so it will be minus infinity to 2. So this was about the linear inequations of type 1. Now moving on to linear inequations of type 2. So type 2, like we are provided with ax plus b upon cx plus d greater than k, or we can say greater than equals to k, or then we can say ax plus b upon cx plus d smaller than k or smaller than equals to k. So when equation is given or linear inequation is given of this type, so for that the rules are, we'll obtain linear inequation, then we'll transpose all the terms on LHS, then we have to simplify the linear inequations which is obtained over here in the form of, that is, we have to bring over here 0 because we are transferring all the terms on the LHS side. So it should come in the form of px plus q upon rx plus s greater than 0 or greater than equals to 0 or less than 0 or less than or equals to 0. Then if the coefficient of x is not negative, will make it positive. Sorry, if the coefficient of x is negative, we'll make it positive in both numerator and denominator. So if you are making it positive, this sign will change. Then we'll equate this numerator and denominator separately to 0. We'll obtain the values of x. These values are called critical points. Then we'll plot critical points which are obtained over here on the real line. These lines then will divide. Let's suppose we have plot point over here. So the line is now divided into 3 regions. So in the rightmost region, the expression on LHS of the equation obtained in rule 6 will be positive, as we know, and in other region it will be alternatively negative and positive. So mark positive sign in the rightmost region and then mark alternatively negative and positive sign. Then we have to select the appropriate region on the basis of the inequation which was obtained in rule 4, and then we'll write it in the form of intervals to obtain desired solution set of the given inequation. Based on these rules only, we'll now solve questions. So the first question is x minus 3 upon x minus 5 greater than 0. Since over here already 0 is given, so we'll directly start from the fifth point, that is, we'll equate x minus 3 and x minus 5 to 0. So when we are equating x minus 3 to 0 and x minus 5 to 0, we are getting x is equals to 3, 5 as critical point. Now when these points will draw on a number line, as we know this is a number line where this part is plus infinity, this is minus infinity. So this is 3 point and this is 5 point. So over here in the rightmost region we got positive region. Over here also we'll get a region which is negative. So this real line is basically divided into 3 regions. In the rightmost region of the expression which we are seeing over here is positive. The remaining 2 regions will be alternatively negative and positive. So since the expression in first is positive, so the solution set, obviously it is a union of these 2 terms. So thus we can say x minus 3 upon x minus 5, it is greater than 0. So this implies that x belongs to minus infinity to 3 union of 5 to infinity. So its solution set of this inequation is given by minus infinity 3 union 5 to infinity. So this is how we have to solve the linear inequation of the type ax plus b upon cx plus d greater than or equals to 0. Coming on to the next question is, now over here the 2x plus 4 upon x minus 5 is greater than equals to 5. So what we'll do, we have to bring this as 0. So we'll transpose this to this side, that is to the LHS side. So we'll get 2x plus 4 upon x minus 1 minus 5 greater or equals to 0. When we'll solve it, will get minus 3x plus 9 upon x minus 1 greater than or equals to 0. As we discussed in rules, when coefficient of x is in negative, we have to convert it into positive. So, we will write 3x minus 9 upon x minus 1 smaller than or equals to 0. As we got this statement, so now we can take 3 common from the numerator part. So, we will get x minus 3 upon x minus 1, which is smaller than and equals to 0. Over here again, now what we will do, equating x minus 3 and x minus 1 to 0. So, we will get 3 and 1 as a critical points. So, 3 and 1 when we are getting as critical points, since over here it is smaller than and equals to 0. So, therefore, we can write over here x is smaller than and equals to 3, but this x is greater than 1. So, the solution set of this particular equation, linear inequation, will be 1, 3, where 3 is included. Since when 3 is included, we put square bracket, and here 1 is not included, therefore, this small bracket we put over here. So, in today's video we discussed what is linear inequation and what are the types of linear inequation, and we also discussed the rules how to solve these linear inequations. Hope you guys are finding my videos helpful. So, do like, share and subscribe the channel. Thank you.